All right, now that we're dividing with decimals, um, we can use that to kind of reason through problems and answers. There's always a connection between decimals and fractions and percents. And so we explore that just a little bit with this section. So it says use long division to show that a fraction and a decimal in a pair are equal. Okay, so what they're saying is 3/4 is equal to 0 and 75 hundredths. You might already know that to be true, but in these directions, they're asking us to use long division to show it. So we take this fraction, 3/4, and we can rewrite it and think of it as a division problem and say 3 divided by 4. So we have to use long division to show that 3 divided by 4 equals 0 and 75 hundredths. Easy peasy, we can do that. 3 divided by 4, so 3 is the dividend. And divided by 4, 4 is the divisor, so that goes on the outside. So it looks like that. So if we're going to use our does McDonald's serve cheeseburgers, and we're going to divide this out, first thing is to divide, and we'll say how many times does 4 go into 3? Well, 4 doesn't even go into 3. It's bigger than 3. So this is where we have to add a decimal and a 0 to make it appear larger than it actually is. So now the problem looks like it's 30 divided by 4. Okay, no problem, we can do this. So we're going to put our decimal right into our quotient because we know that's what we do when we divide with a decimal and the dividend. And we know that 4 didn't even go into 3, right? But 4 can go into 30. So 4 can go into 30 7 times. Then we multiply 7 times 4 and we get 28. We subtract, and 30 minus 28 is 2. We check to make sure 2 is smaller than 4. We bring down, well, there's nothing to bring down, so we can always bring down another 0 when we're dealing with decimals. And then we divide and start all over again. So how many times does 4 goes into 20? It goes in there 5 times. Then we multiply 5 times 4 and we get 20. And we subtract and we get 0. So 3 divided by 4 is in fact 0 and 75 hundredths, just like the problem stated. Good, let's try another one. Take your notes right along with me and rewrite them just as I'm doing. So we have to show that 3/50 is the same as 0 and 6 hundredths. First thing I want to do is rewrite 3/50 as a division problem. So 3 divided by 50. And if we're going to write it like that, we've got our 3 inside. And the divisor is 50. Well, same problem as before. 50 is larger than 3, so I'm going to have to add a decimal, and this time I'm probably going to have to add 2 zeros. And my decimal point goes right up into my answer. All right, so I know 50 can't go into 3, and 50 can't go into 30, but 50 can go into 300. So if I'm thinking of 5 into 30, that should be 6 times. I can also show my math work off to the side here and say 50 times 6 is 300. 6 times 50 is 300. I subtract and I end up with 0. So I've just proven that 3 divided by 50 is the same as 0 and 6 hundredths. Let's try one more. We need to prove that 7/25 is the same as 0 and 28 hundredths. First thing I'll do is rewrite 7/25 as a division problem. And then I have to put my 7 on the inside. That's my dividend divided by 25 on the outside. Looks a little backwards. Again, I'm going to have to add a decimal point. and put that decimal point straight up into my quotient right away. I know 25 can't go into 7, but it can go into 7D. If I'm thinking quarters and money, 2 25s are 50 cents and 3 quarters are 75, so it's only going to go in there 2 times. And 2 times 25 is 50. And I subtract, and 70 minus 50 is 20. 20 is smaller than 25, so I've checked that, and I have to bring down because I'm not done yet. So I'm going to bring down a 0, and then I have to think 25 into 200, think quarters into $2, and I should come up with 8, and 8 times 25 is in fact 200. I could do my math right off here to the side if I needed to. And 200 minus 200 is 0. So I have, again, proven that 7/25 is the same as 0 and 28/100. All right, let's look down at this problem below. It says to find the decimal of 9/25, Tyler reasoned that 9/25 is equivalent to 18/50 and a 36/100. So the decimal of 9/25 is 36/100. It says use long division to show that Tyler is correct. Okay, so let's do this. We're taking this one right here. We're going to rewrite our 9 divided by 25, 9/25, and we're going to prove it. So let's put our 9 down here. Let's divide it by 25. Again, it looks a bit awkward, so we're going to add our decimal and our 0. Put our decimal right in our answer. And think quarters. And again, how many 25-cent pieces goes into 90? I think we can get it 3 quarters in there. 3 times 25 is 75. If I didn't know that, I can do that off to the side to get 75. And 90 minus 75 is 15. And then 15 smaller than 25. I've checked that. I need to bring down another 0 because I'm not done yet. And again, I'm looking at 25, how many quarters out of $1.50? So I'm confident then that I can get 6 out of that. And I can do my math over here just to be sure if I need to. Yep, that is right. So 6 times 25 is 150. Subtract to get 0. So I did prove that 9/25 is the same as 0 and 36/100. Part B says, is the decimal of 18/50 also 36/100? Use long division to support your answer. Well, it should be. If this is the same as this, they should all be the exact same decimal. But let's double check just to be sure. So we rewrite 18 divided by 50. We're going to end up with our 18 divided by 50. Again, we see that we're going to have to add a decimal point and a 0. And think 50-cent pieces now, or 50 cents out of a $1.80. Probably looks like I could get 3 out of there. And again, 50 times 3, I can do my math off to the side to get 150. Subtract to get 30. Check to make sure it's smaller than 50. Bring down because we're not quite done. And how many 50 cents can you get out of $3? You can get 6. 50 times 6, 300. Subtract, and yes, we were able to prove that the decimal 18/50 is the same as 36/100. So we can use our ability to show long division with the traditional algorithm to prove and reason that decimals equal certain fractions, and we can show it with our long division. All right, thanks for listening.